Hi, this is Leanna from Period 5, and here we are looking at our data that we collected from the lab, the net force versus acceleration lab. First, let's take a look at our y-intercept, and as you can see, it's not at 0, but if you look, it's only about 0.14 newtons, and that's very small. And if we go back to one of our basic ideas that we learned way back in that helicopter simulation game, if we have 0 acceleration, we'll have 0 net force. Like the sum of all forces acting on the object will be 0. So this y-intercept actually should be 0, but due to our equipment not being very precise, it was a little bit above 0. But that's okay, we'll just ignore it and pretend that it's 0. Which would mean that when there's 0 acceleration, there's the sum of all forces acting on our car is 0. Now we'll look at the slope. It's about 0.86 newtons over meters per second squared, which means that for every unit of acceleration, the net force changes by about 0.86 newtons. And when I was doing the lab, I didn't realize the relationship between the slope and the mass, but Mr. Day explained it to me that the total mass of the objects that we were using, like the car and all of those little all those little masses, those circular masses, the total mass of our system that we were using, it should have added up to about 0.86 kilograms, I think, or at least close enough that we can say that the slope of our net force versus acceleration graph is actually our mass, the total mass of our system. So we know the mass never changes. That leaves us with net force and acceleration. What's their relationship? If we look at the graph, it's sloping upward, and it's increasing, which means that as the net force increases, so does the acceleration. But we can't argue that the net force is identical to acceleration. We can only argue that it has the same direction because net force and acceleration are both vectors. That leaves our mass as a constant. So basically, if we multiply the acceleration by our mass, the constant is the determining factor for what our net force is going to be, based upon the mass multiplying by acceleration. And that should equal the sum of all forces. If our net force is constant and we have unchanging mass, then our acceleration is going to have to increase or decrease so that its vector length will equal that of the net force's length, vector length. And so there's the relationship. They have an inverse relationship.